Hello all, welcome back. In this video, we are studying how to create and traverse a singly linked list. Okay, we are studying with the help of code. Let's say linked list is made of structure like this, struct node. Inside it, there is an integer int data and then struct node star next. It means that our node is going to contain two elements. One is an integer and other is a link to the structure of same type. Head is a pointer that is pointing to the first node address. Okay, this void create list and void traverse list. These are to create and display a single linked list. We have to declare a function of creation and traversing the list using these two functions. Going to the main part, this is the n declaring the variable. We have to enter total number of nodes, how much nodes in linked list during creation and traversing. Then we have to call create list, but before this we have to see how to create a list. So going to the part of create list. Here we are. Let's create the singly linked list first. Then the traversing is the next part. Declare two variables of node type, that is star new node, star temp. Data and I are variables of type int used later in the code. Okay. Now create first node, that is head, using dynamic memory allocation to allocate memory for a node. We create a node using malloc. As we want to create a structure by name node, so we try to find the size of that structure in our operating system. Assuming size is fixed, so it can be calculated by the operator size of. So, size of struct node send to the malloc. Okay. As malloc returns void star, so we have to do the typecasting. So this is the part of typecasting. Casting to the pointer of type node. Now, if head equal to null means there is no memory allocate for head node. So, we have to print error message unable to allocate memory and terminate the program using exit and in brackets 0. Otherwise, we have to take input data from user and assign it to head using head arrow data equal to data. Then head of next equal to null means firstly head node points to null. We will see the linked list fully created before traversing, but before this, let's code it completely. Okay? With this, we are done with head node. Now we are creating other nodes. For this, we are copying reference of head to temp. Temp is a temporary variable. We will use this temp to store reference of previous node. Same procedure applied for the new nodes. This for loop is used to create all the nodes until n. In this for loop, we are allocating memory and assign memory reference to new node. Same as we done for head node. Okay, if new node equal to null means memory is not allocated to new node. So we have to print error message unable to locate memory and then break it. But if memory got allocated successfully, then we are reading data and assign it to data section of new node using new node arrow data equal to data. Firstly, new node points to null. So new node should point to null with the help of new node arrow next equal to null. With temp arrow next equal to new node, we are linking previous node with newly created node. We will repeat this for other nodes too. We created a list successfully like this with the above code. This is the first node. containing value 1 and containing the address of next node in its link part. Assuming second node as having value 2, it also contains the address of its next node. It has address 2001. Its link with the third node having value 3 and having address 4001 of next node. Its address is 3001 obviously. And this is the fourth node having null in its link part and its address is 4001. With the above code, we have created this type of list. This first node is having address 1001. We already know that address of first node is in head pointer, right? And a head pointer always points to first node. Let's create one more pointer, that is temp. We will use this temp in traversing a linked list, and initially it is also pointing to first node, so it also contains 1001. Concept of this temp node is also used in traversing. So this is the list we created using the above code. Now let's traverse this list with the help of code again. Okay? Now it's time to traverse it. Are you ready? Okay. We already declared this traverse list function above, and now we are using this after creating a list. Okay? To traverse the entire list, we have head. Then take first node, print it, second node, print it, and so on. Means keep on moving the head and print it. We made a linked list where head is pointing the first node. So we put 1001 in this, but during traversing we keep on moving the head and print 1, 2, 3 and so on. But moving head pointer is really dangerous, because once you move the head pointer to point to the next node, then previous node will be permanently lost. That's why we created a temporary pointer temp using struct node star temp. We created temp and initially temp also pointing to the first node. Right? Means it is a structure of type node, and now using this temporary pointer I can move. If head equal to null means list is empty, so we have to return. Okay? But if it is not the case, take temp equal to head means initially I have a temporary variable temp, and temp is also pointing to whatever head is pointing to, and using this I can keep on moving and keep on printing it. Now I am trying to print temp of data. Means whatever data I am going to print, it using printf data temp of data. So one will be printed, then I will go to next one and print it. So this is the reason I will move temp to next node using temp equal to temp arrow next. Means value of temp present in next pointer. Initially head contains 1001, right? We made a linked list and head contains 1001 and temp also contains 1001. So 1 will be printed. Then temp contains 2001. It keeps on moving, na? So 2 will be printed. Then temp contains 3001 and 3 will be printed, and so on. I have to print again and again. So I put it into while loop. While temp not equal to null means until it is empty, it will print continuously. This is how we can print the entire singly linked list. Okay, let's see the output too. According to our linked list, we made 4 nodes, right? We put 1 on the node 1, 2 on the node 2, 3 on the node 3, and 4 on the node 4. And nodes are 1, 2, 3, 4. This is using creation of linked list code, and this is using traversing of nodes. So, this is all about creation and traversing in singly linked list. So stay tuned and enjoy learning. And yes, if you have any queries regarding this video, feel free to contact us through our email, LinkedIn, Twitter, Facebook and Instagram. And don't forget to press the bell icon to stay updated. Thanks for watching.